Hello everybody, it's Tidominer and welcome to the third part of making a sliding puzzle game in Unity. In the previous parts we created this game. We can move the tiles. Also, when they are in their correct position they become green, but in this part we're going to make the shuffle system for our puzzle tiles. So let's open the game script. In here we need to write an array of tile scripts for our puzzle tiles. So let's write serialized field tile script, put two box brackets in front of it. Now let's name it tiles. We can find our puzzle tiles using a code and save them in the array, but I'm going to do it myself in the Unity editor. Select the main camera, you can see tiles array in here. Click on the triangle near it. There is a field named size. It's the size of our array. So let's write 16 in here. We have 15 tiles, but we need an empty element for the empty space. Now let's add our puzzle tiles to the array. So drag them inside the array elements one by one in order of 0 to 14. Now we assigned all of our puzzle tiles to the array, so open the game script. In here we need to write a void, name it shuffle. We're going to shuffle our puzzle tiles in this void, but how are we going to do that? We have to change the position of each tile with another random tile. So in here let's write a for loop, for int I equals 0, if I is less than 15, I plus plus. When we are shuffling our puzzle tiles, we don't want to move our empty space, and you can see our empty space in this array is a null element. So let's write a statement if tiles number I is not null. It means if it's not our empty space. In here let's create a variable to hold the current position of this tile. So let's write var last pose equals to tiles number I dot target position. Now we have to select a random tile to swap their position. So let's write int random index equals to random.range. Random.range returns a random number between two numbers. We need a random number between 0 and 14. We have to write 14 in here because our 15th element is our empty space. Also, we can remove this statement and change this 15 to 14 in the condition of loop. So we won't change the position of the empty space anymore if we write 14 in here. Okay, now let's swap the position of these two tiles. First, let's move the tile number I. So let's write tile with the I index, the target position equals to tile with random index dot target position. Now we have to set the target position of our tile with random index to the last pose. Now we have to call the shuffle void in the start to shuffle our puzzle tiles when the game runs. Now let's play the game and see what happens. Now we can see there is a problem. Some of our puzzle tiles goes to the center of the screen. For solving that problem, just open the tile script. In here we have to change the start void start to void awake. Void awake getting called at the start of the game like void start, but it's getting called before start. So now when all of our puzzle tiles save their target positions, then our game script shuffle the tiles. It looks tile number 15 doesn't move. Let's play the game again and see. Okay, it doesn't move. Let's open the game script. In here, let's see what's the problem. Okay, in here we have to write if I is less than equal 14, not just less than. So let's add the equal after the less than sign. Okay, now let's play the game and see if it works. Okay, you can see now the tile number 15 moves too. Okay, the shuffling system works good, but there is a big problem. When we shuffle our puzzle tiles like this, sometimes our puzzle becomes unsolvable. It means you can never solve it. And we have to check if our puzzle is solvable or not. If it's not solvable, we have to repeat the shuffling until it is solvable. But how to see if it's solvable or not? First, we have to arrange the tiles in the array as we see them in the game. This is our puzzle board. As you can see, it is sorted from 1 to 15. And this one is our array of tiles. The tiles in the array are also sorted from 1 to 15. When we move tile 12 down, square 11 becomes empty and tile 12 goes to square 15. We need to do this inside the array as well. We need to do this for checking the solvability of our puzzle. So open the game script in the shuffle void in our loop. We have to swap the position of tile with random index with a tile with I index. So let's write, first we have to hold the tile with the I index. So let's write var tile equals tiles number I. So now we're going to move the tile with the random index to the tile to the position of tile with I index. So let's write tiles I equals to tiles with random index. Now we're going to move the tile that we saved in the tile variable to the position of tile with the random index. So let's write tile random index equals tile. Now let's return to the Unity editor and play the game and see what happens. Okay, you can see our puzzle tiles shuffled. Also, the index of our puzzle tiles in this array changed. In the game board, the first tile is tile number 3, and our tile number 3 game object name is tile 2. Also in our tiles array, the first element is tile 2. And the last tile in the board is tile number 9, and our tile number 9 game object name is tile 8. Also in our tiles array, our last element is tile 8. When we shuffle the puzzle tiles, we also change their positions in the array. Now we need to change their position in the array when we move them by clicking. When we click on a tile, we know which tile we clicked on, but we don't know its index in the array. So let's write a method to find the tile index in the array. In the game script, let's write public int find index open parentheses tile script ts open brackets. This integer, this method returns us the index of a tile script in our tiles. So we have to check all of the tiles and compare them with the tile script that we receive in the method. So let's write loop for int I equals 0 if I is less than tiles.length I plus plus. In here, first we have to write a statement if our tile number I is not null, because when it's null it is our empty space and Unity shows us some errors and we don't want that. So let's write if tiles number I is not equal to null, then we have to write another statement if tiles number I is our tile script, if it's equals to ts. If it's the tile that we are looking for, then return the index, return I. After the loop, we have to return -1, because when we write a method like this, an integer, it has to return a number. In this case, we return the index of the tile under some conditions, and if, for example, if the tile ts is not inside the tiles array, it won't return a number. So we have to return a number anyway. So let's write return -1. Now let's return to the update. In here, when we click on a tile, first let's find the index of the tile. Let's write int tile index equals find index. We're using our method to find the index of the tile, and we're going to find the index of this tile. Okay, let's write this tile. And in here, we after finding the index of the tile, we have to swap the position of that tile with empty space, just like we did in the shuffle void. So let's write tiles with empty space index equal to tiles with tile index. In here, we make a copy of the tile that we clicked on, and we're going to save it in the empty space index in the array. And now we have to write tiles with tile index equals to null. So we swap the position of the empty space and the tile that we clicked on in the array. Also, we have to change the empty space index after this. So let's write empty space index. It equals to the new empty space index. Tile index. Now, if we play the game and move a tile, you can see its position in the array changed too. Also, we need one more thing. We need to know the number of each tile. So let's open the tile script. In here, we need to write a public variable. So let's write public int number. We have to write the number of the tile in this variable. So open the Unity. In here, we have to set the number of each tile one by one. Let's select the first tile. It's tile 0, but it has number 1 on it. So let's write 1 in this number field. And we have to do this for all of the other tiles. The last thing that we need for checking the solvability of our puzzle is inversion of puzzle tiles. Inversion means the number of tiles with a larger number that exists after a tile. Let me show you what inversion means with an example. In here we can see our puzzle tiles are shuffled. If we want to calculate the inversion of tile number 13, we have to check the tiles after the tile number 13. 11, 5, 14, 15, and 2 are the tiles after the tile number 13. But we have to see how many of them has a larger number. 11 is smaller, 5 is smaller, 14 and 15 are bigger, but 2 is smaller. So just 2 of them has a larger number than 13. So the inversion of tile number 13 is 2. For getting the inversion of the puzzle tiles, I wrote a method before. This method returns us the total inversion of the puzzle tiles. I don't know how to explain it, so I'm just going to copy and paste it. If you want it, I'll put a link in the description. You can get it from there. When we have a puzzle like this, a 4 in 4 puzzle, and the empty space is at the right bottom, when the total inversion of the tiles is an even number, our puzzle is solvable. But when it's not, the puzzle is not solvable. If you want to make a sliding puzzle with a different size, I'll put a link in the description to an article. You can read the article and find out how to check the solvability of your puzzle. In here, for checking the inversion, we need to use a do while. But what's the difference between a normal while and a do while? When we are using a do while, it runs the code inside the do section. Then it checks the condition of the while. If that's true, it keeps repeating the do section until the condition is false. It means our code in do section will get executed at least for one time, even the condition is false. Now in our shuffle void, let's start by writing an integer variable for our inversion. So let's write int inversion. We're not going to give it a value now. We have to calculate the inversion after the shuffling. Then let's use the do while. So let's write do open brackets. I'm going to put the shuffling inside the do. Then after that, we have to write while. So it means it will shuffle our puzzle at least for one time. Now in here, we have to check if the inversion is an odd number. If it's odd, we have to repeat the shuffling, because when it's even, our puzzle is solvable. But how to see if the number is even or odd? But how to see if a number is odd or if it's even? You have to check the remainder of dividing that number by 2. If the remainder is 1, it means our number is odd. If it's 0, it means our number is even. So in here we have to check if our number is an odd number, because when it's odd, it means it's unsolvable and we have to shuffle the puzzle again. But how to get the remainder? We have to use the %mark inversion %mark2. It means the remainder of the inversion by dividing by 2. If it's not 0, It means if it's not even, then we have to repeat the shuffling. It shows us an error because we haven't assigned a value to the inversion yet. So after the shuffling, let's calculate the inversions. Let's write inversion equals get inversion. Now we calculate the inversion and we save it in the inversion integer. Also, I'm going to write to debug the log that says puzzle shuffled, so we can see how many times our puzzle gets shuffled. It's good, but we need one more thing to do. When we have a 4-in-4 puzzle and the empty space is at the bottom right, and the inversion of the tiles is an even number, it means our puzzle is solvable. But when the empty space is not at the bottom right, it's at another position. In that case, when the inversion of the tiles is even, it doesn't mean the puzzle is solvable. We have to make sure that the empty space is at the bottom right. So before the shuffling, we have to move the empty space at the bottom right, then do the shuffling. So let's write in a statement before the shuffling. Let's say if the empty space index is not 15, if the empty space is not at the bottom right, so we have to swap the empty space and the tile that is at the bottom right. So let's write tiles empty space index is equal to tile with the 15 index, and then tile with 15 index going to be null. So we just swapped the empty space and the tile that is at the bottom right. But now we just swap their position in their array. In the array, we have to change their positions too. So before these lines, let's write var tile on 15 last pose. It's a variable for saving the position of the tile at the bottom right. Tiles with 15th tile dot target position. Now let's move the tile at the bottom right to the position of empty space. Tile with 15th index dot target position equals to empty space dot position. And now we have to move the empty space to the bottom right. Empty space dot position equals to tile on 15 last pose. And also we need to change the empty space index. So let's write empty space index equals to 15. And that's it. Let's go back to the Unity editor and see if it works or not. Let's play the game and see what happens. Okay, you can see it shuffled our puzzle one time. Let's play it again. And this time it shuffled the puzzle 2 times to get the solvable puzzle. Again, 1 time. But this time it shuffled the puzzle 3 times to find the solvable arrangement. And it shows that it works. Now let's try to solve the puzzle and see if it's really solvable or not. This video finishes in here. In the next part, we're going to make a timer for our game and add some buttons to the game. I try to upload the next part soon. If you liked the video and learned something new, like the video and subscribe my YouTube channel. And if you have any questions, ask it in the comments. I try to answer them. Thanks for watching. See you in the next video.